Oh, that makes more sense. So, what strategies and trends do you look for in matching slope field? Number one. What? One. Does the function depend on y? Alright. If it depends on y, that means that there should be no horizontal change in the slopes. Okay, so if I have a function that is just y, the slope should mirror horizontally. Two depends on x. So if it depends on x, the slope should mirror vertically. Right? Zero slope or an undefined slope. So you can look at a function, you should be able to look at a function and say, well, I should have a zero slope somewhere. Okay. Or an undefined slope somewhere. What does it look like?
The only one that wouldn't have either of those is a straight line, huh?
Yeah, you would never have an undefined slope if you do not have something inside, like a denominator. If you don't have a denominator, you're not gonna have that much.
But for every like function will have a zero slope unless it's just x, so like the shape of it.
Well, if your function doesn't have a constant, then you should have a zero slope.
Like just a number.
Yeah, because these are differential functions, which means if I have a number, that's the slope.
Oh.
So if I don't have a constant anywhere, then that's possible I'm going to have a zero slope. All right. We kind of did this yesterday. Any quadrants? All positive or all negative? Are the slopes always positive? Is your function positive everywhere? Where the slopes one over four. Yeah, because we're gonna match the equation. I had the class right down the show. Yeah. I started, I had on the board and there's right down here.
Oh.
Alright, where are slopes not existent? I mean, if you look at like D, and E, both of those have part of the graph where the slopes do not exist because the function doesn't exist.
Why did you change?
Does that like put-
Oh, they're like they don't go together or anything.
No,
Oh, okay. Oh, it's I really okay. Oh, let me see.
let's look at this first function. Okay. The very first function here. This function is a little special because do I have an area where the function doesn't exist? Yeah, where does the function start at? -2. So where x is anything less than -2, my function cannot exist. So this should be pretty easy to determine which graph is D, because x must be greater than or equal to -2. Right. But let's look at E as well. Let's look at E as well. Now notice that my domain, I don't have a domain restriction, I have a range restriction, which means my function should be in terms of what? So that's y. And I have limits on what y could be. So that means it's not 2 or 3 or 4. It could be 5 or 6, because those are functions of y. But it has to be 5 because what?
Because no.
1, y is in the denominator, so it means y can't be 0. But 2, y is also the natural log, and what can you not have in natural log? Negative. So here's y. Oh, I was looking at the easy functions first. Just gotta jump around here. Is that going back there? So yeah, number 5 is E because y must be greater than 0. So that's the easy ones to look at because we have specific restrictions on it. Okay. Now we talked about the very first one. If it depends on y, it depends on x. So we only have one function that depends on just y. Right? So there should be one function to where the entire graph mirrors horizontally. Okay. So which function has every slope the same as you go across horizontally? Which graph is it? Okay. Well, see here, these values change horizontally, right? C, none of my values change as they go horizontally. So C is 6. Those on Y. So,
Good morning, guys. If you have a library calculator that you checked out from me, will you take a minute and see me in the hallway to renew it? But if your calculator has a barcode, just take a minute, bring it up.
all right, we have two functions that are dependent on just x, which means my slopes do not change vertically. Okay, so we have number 2 and number 4. Okay. So H doesn't change vertically. What else doesn't change vertically? A. Which means 2 and 4 are either A or B.
Wouldn't 4 be H because it's 0 times, so we have.
Yeah. Look at graph does move that cosine wave. So yeah, 4 is A. Which means 2, but 4 is H. Yeah.
And 2 is A then?
2 is A.
8 is.
So it depends on x, on x, and get cosine wave.
3 is G.
3 is G. Why is 3 G?
Because it can't be 0. And there's nothing on 0.
Yes.
Wow, you're so smart.
3 is G. You're correct. This is a good explanation. So undefined when x is 0. So that leaves B and F.
I think 7 is B
Why?
because it changes for X and Y, but it like reverts at the X axis. Like it switches because it's regular.
Size. Notice that all your slopes in the quadrant 1 are negative. All your slopes in quadrant 2 are positive. All your slopes in quadrant 3 are negative. All slopes in quadrant 4 are positive. So that means that when x is positive, when x and y are both positive, I have a negative slope. Would that be true for number 7?
Yes.
Yeah. So yeah. B.
And then F is 8 because it has the waves again, but it also has the,
Sorry, what?
are there diagonal asymptotes in? Or in F, maybe, no, I don't know, it's just a weird looking graph.
It is one meter.
It's cosines too.
It is.
But yes, it's kind of weird cosine one there. We do kind of have like a diagonal symmetry there. But alright, when do we get 1? When do we get slope of 1? When does cosine give you 1?
At 0.
At 0. Alright, so when would I have 0 in that function?
At -1 plus 1.
So whenever x is equal to negative y.
Yeah.
So basically, whenever x and y have opposite signs, okay, I have a slope of 1. And if you notice this, yes, this is a here at -1, 1, -1, 1. All these values right here all have a slope of 1. So, one, and x equals -1. Here, is
Yeah, all done.
yeah, that's it. Slope is positive in Q2, Q4. Slope is negative in Q1. Yeah, that was it. So you have two depth methods. One for just the difference equations, and then one is just the slope field.